In 2014, the direct control screen of the Mentor has been upgraded with a new set of tools which greatly improve the efficiency of the testing process. Within the next few minutes, we will visit and briefly describe each of these new tools. The values viewer. Any situation that is created in terms of voltage, currents, and phase angles into the main control screen can be seen from now on in terms of the different electrical parameters that are more frequently used in the relay testing. By default, there is the vector representation, which is one of the ways to see the adjusted values. By clicking on it, we start the sequence of views available. The first one is the sequences, is seeing all the values in terms of zero, positive, and negative sequence. Then the voltage and current, which is a reflect of the actual screen. Then in power terms, then in line versus in voltage line and 3 UO, or in open delta. Coming back to the vector view. The selected view, say this is sequences, remains indicating in real time its variation while the fundamental parameters, voltage, current, or phase angle, are regulated. So we also have then the vector view. Sometimes, when varying values, it is more convenient or intuitive by direct manipulation of vectors instead of entering just numbers. By clicking on the button Vector View, this control is displayed to you. By touching the tip of each vector, dragging on the screen, both the vector's model and or the phase angle can be selected to the desired values. To move the vector in three-phase or phase-to-phase terms, they need to be linked together by selecting them here. To move only the vector model, block the phase angle by clicking here. On the contrary, block the model and move only the phase angle. To move back to the main control screen, click here. The assisted control is clicking on the assisted control button. We enter into the specific setting tools, which not only avoid calculations and possible errors, but saves an enormous amount of time in the testing process. The operator needs only to insert the required relay settings values that defines the desired test parameters on each tool and just inject to the relay by clicking on the on-off button. There are different tools. The first one is the impedance, designed to test distance relays in a very easy way. The operator only needs to set the full loop to be tested, AN, single phase loops, AN, BN, CN, phase-to-phase loops, AB, BC, CA, and finally the three-phase fault loop, ABC. The test is always made at the constant fault current, and the operator must insert the fault current value in the iFault window. Then the prefault current value, which is recommended by the way to keep at 0, must be inserted in the iLoad window. Then the operator must insert the desired test point values in impedance terms, so in ohms. It can be made in Cartesian terms, inserting the R and X components of the impedance vector, or in polar terms, inserting the impedance module and its phase angle. One of the most cumbersome part of the calculations in the distance relay is the ground compensation factor application for phase-to-ground faults in order to calculate the voltage and current values to inject, which will be correctly interpreted by the relay. This calculation is not necessary, as the operator need only to insert the relay setting for the ground compensation value, which can be given in terms of KE equals to ZE over CNL inserting in this case the Ka module and the Ke angle, or in Re over RL and Xe over XL. Inject just the fault, then by clicking on the on button, the relay will trip and the trip time will be shown in the timer display. Then you may repeat your test for the different fault loops just by selecting them. Easy, isn't it? The next tool is fault, which allows the operator to insert the desired fault values, the fault voltage, the fault current, and its phase angle. Then these fault values will be applied to the different fault loops just by selecting them on the screen. The next tool, power, allows the operator to select and regulate directly in terms of power. Traditionally, it is, along with regulating impedance terms, one of the most complicated tasks to perform due to the calculations required. The distance tool removes the need of performing any of these calculations and make the task of regulating power a child's game. The operator needs only to select the terms on which he wants to regulate power, either P, active power in watts, and Q, reactive power in VAR, or S, apparent power in VAs, and power factor, or cos phi. In both terms, the operator is able to regulate in single phase to obtain any possible unbalanced power situation, or in three phase, which is appropriate to work with balanced power situations. To activate the output, click on, and to step from this situation to another, click Lock, and the actual values will remain in the output while you regulate a second power value to step. And click again on Lock. The actual regulated power will be active immediately. The next two sequences allow the operator to select and regulate directly in terms of positive sequence, negative sequence, and zero sequence, not only in module but in phase angle also. The next tool, D-line, allows the operator to select and regulate directly in terms of line voltage face to face, and also in the zero sequence voltage C3UO. Thank you very much.